No, I've given that up. Can't afford to have any complaints. Yes. Yes, I've done 8 of the questions, and Mr. Weaver doesn't know it, but he's going to do the other 2. And I got them done this morning, finished them up this morning, so that there's some on tasting, there's some on odor materials, there's some on systems of tasting, there's some on the lecture today. Can't think of what other things. There's some on varieties of wine varieties in California. It's not very much different than the usual final I give, except that it's brand new. I did it all out of my own little head this morning. Worked hard at it, as a matter of fact. Had some extra time, you see, Randy doing the lab. Okay, then the 4th thing is the question of next Monday. To make that meaningful, you have to cooperate. Otherwise, it's going to. We're going to be out of here at 1:15. Now, if you just want to slay me, why you don't need to warn me ahead of time. But if you have some hard questions or some questions that you think are really hard, why I'll be glad to receive the question anytime this afternoon or Monday morning, and I'll answer as many questions as I can in the time for 1 o'clock. My experience has been that people don't like to ask questions because they're afraid that I'll put the questions in the final examination. So that's why I've gone to the trouble to explain to you that I've already made up the final examination. So if you ask the question, it's on the final, I'll answer it. Equally, it's all right with me. I won't tell you what the questions on the final are, though. That's another matter. All right, any other questions then? Yes, ma'am.
Is there questions session scheduled for next Monday?
That's right. We will not have a lecture. There will be questions next Monday, questions on any part of the course that you want. Try and keep it on this course, however. You'll have plenty of time to ask Professor Berg about his. Now, the 5th thing was I still am missing some lab reports. If your name is there, why, let's get at it as quick as we can. Too sweet, that's right. Well, I don't know about this particular lecture. With the consumption of dessert wines going down and interest in dessert wines certainly going down, grape plantings for dessert wines certainly decreasing, no new attempts by wineries to change their dessert wine production. In fact, the big thing is to convert from dessert wine production to table wine production in practically every winery in California, big and large, southern and northern and central. On the other hand, we still sell about 60% of our total wines is fortified in one way or the other. That includes some flavored wines and vermouths, as well as the true dessert and aperitif wines. So that represents a very big volume. And even if only 10% of that is a quality industry, it still amounts to a fair-sized industry. And we ought to see what ways we can do to make it a better industry. Perhaps one of the problems has been that we have catered to a rather cost-conscious dessert wine market, and not very many high-priced wines or high-quality wines have been offered for sale to build up the reputation of the whole industry. You can make a fair case out of the fact that the table wine, interest in table wines came about, at least partially, because California began to produce better and better table wines. People discovered they were very good, and so the whole interest in table wines at all price levels, at all quality levels, immediately increased. And we got this big expansion of the 1960s in table wine consumption, which is continuing into the 70s. Well, I have no way of proving that thesis. I'm just saying that you can make a case for that. And so you might also make the opposite case, that the decrease in sales of dessert wines has been that there have been practically no high-quality, well-aged dessert wines offered for sale to the American public, and therefore how could they ever get any interest in dessert wines when a great many of them were just offered as cheap substitutes for alcohol at very low prices, very nominal prices. Well, I can't prove either one of those theses, and I'm not sure that anybody else can. But we'll talk about some methods of improving dessert wines today. And I want to talk first about the film yeast sherries. You've had some of this material in 24, excuse me. And so that part will be just a review, but since a good part of the work was done by Mr. Rowe and myself, I think maybe another point of view might be of interest. One is that the old Beticus, which is what we've been teaching our classes, is the wine yeast, went down the drain 2 years ago and was now called what? Beanis. Along with all the other changes, the ellipsoides disappeared and oviformis disappeared and so forth. The new edition of ABC, the third edition, has these new names in it at considerable cost to Professor Berg and myself to figure out all the changes that went on. At any rate, the film yeast is available now under the name Saccharomyces bayanus, and the best results that we've obtained with it has been when it was in active fermentation, fourth and fifth day of growth, sometimes sixth day of growth. If you're going to inoculate it as a film on barrels, however, you should wait till it begins to form a film. That's much more successful. But when you're going to use it for submerged culture work, then you can use it when it's just over the logarithmic phase of growth, around the fifth day. The inoculation, we've been inoculating from 3 to 5% quite successfully. I understand the industry people who are using this now at Modesto and Tulare and elsewhere have been doing about the same. If you take a film yeast, and put it on a barrel, that is a 50-gallon barrel, it takes about 4 years to develop a good deal of film character. If you take 100 gallons in a 1,000-gallon tank, it'll also take 3 or 4 years to develop very much character. That seems an awfully big waste of space, but unfortunately we don't have any large surfaces available except in big tanks. So the people who have been using film yeast, or that did in the past, I don't know of anybody that's doing it right now, have sacrificed those big tanks, sometimes 10,000-gallon tanks with 1,000 gallons in them, but it takes quite a bit of time. Some attempt has to be made, no matter where you're going to make a film yeast or a submerged culture, to get some sort of evenness of temperature. Otherwise, the film will break when the temperature changes. It will break, normally does break in Spain twice a year. It breaks as the temperature rises in the August, when it gets very warm, and then it will start to grow again in the fall when the temperature gets more normal, and it will break again in the middle of the year when the temperature is too cold, and begin to grow again early in the spring. My own estimates of the Spanish sherry industry are that they don't get more than 8 months of film per year, normally. Although some people are attempting to keep their cellars at more even temperatures nowadays, and they may be getting as much as 10 or 11 months of film yeast on them. Professor Cruz noticed that same thing in California in his experience, that the wineries that put their film yeast barrels in a reasonably constant temperature had a much quicker development of the flora than those who put them out in the fermenting cellar where it was hot in the summer and cold in the winter, and the film was breaking twice a year, or sometimes only once a year. The actual temperatures of around 65 to 70 seem to be quite satisfactory for the film yeast. It will grow faster at a little higher temperature than that. We've grown them up at 80 without any difficulty at all. You can keep them going the year round. There's no doubt about that. In fact, they do that in Spain, in a district north of the sherry district where the cellars are all underground. And when I was on sabbatical there some years ago, I went to visit this particular area, and sure enough, it was right in the middle of the winter when it was freezing outdoors. All the tanks down underground had the film yeast on them. And they claimed that they were able to get a speed up of almost double under these conditions. I don't think it's quite that much, but at least it will be more if you keep the film yeast going constantly. Now, in the submerged culture thing, as I said, you need yeast in active growth, and in both cases, the alcohol content is very critical. If you get below 15%, you will get some acidification. It will be chewed up or metabolized by the Bayanus when it gets into a film. But it's much better not to form that acetic acid. And the best results that we've had, whether in the barrel or in a submerged culture tank, have been when the alcohol content is between 15 and 15.5. And that ought to be fairly accurately adjusted. You can make them grow at 16, and we have made them grow at 16. But it's rather slow, and it's a little touchy in getting them to start it. So we haven't done very much of that. Contrary to the usual belief, but well documented in the literature, you do not want them to be real low in acid. You want them to have some acid, and the pH seems to be as important as the acid here, as you'd expect. And pHs of around 3.5, 3.55 seem to be about the maximum that we should tolerate. This accounts for the great attention given in the sherry district itself to plastering, adding calcium sulfate to increase the acidity, or the amount of attention that's given to adding tartaric acid, both during and after the fermentation. Now we believe, Mr. Rowe and I at least believe, that the oxygen tension is quite critical. It's quite possible to get submerged cultures to produce acetaldehyde with stirring in the presence of air. And this has been done down at Fremont at the Weibel Winery. But our experiences has been it's much better to put it in a closed tank so that you don't get any contamination, any possible contamination, and then bleed in oxygen. It doesn't take a great deal, but it takes enough oxygen so you can see the bubbles coming through so that the entire wine volume is saturated with oxygen. Usually best to put these in through some sort of sintered glass filter or something that breaks up the bubbles real fine. There are a number of these little devices that are available. It's very wise to periodically taste the samples to see how the sherry character is coming along. That's one reason, just to see how much floral character you're getting. Second, you should analyze the samples from time to time. Mr. Rowe and I were very careful to analyze our samples, sometimes at weekly intervals, to be sure that acetaldehyde was being formed. In the submerged culture, that's particularly critical. You don't know whether you're really ready to go or are going, or whether it's already gone for sure, unless you do analysis quite regularly. We also ran yeast counts on all of our fermentations. And I see no reason why wineries shouldn't do yeast counts either. This will tell you whether the yeast are multiplying or not multiplying, and whether you have a viable culture going in the wine. Once in a while, a culture will just die out. And you're sitting there, the wine is oxidizing, and you don't know it. And you keep running analysis, and the acetaldehyde doesn't change, and you wonder what's wrong. Well, if you just do a little bit of plating and a little bit of counting, you would see that there were no viable yeast cells who probably have all died. And you ought to get another culture started as soon as possible. The third thing I think that needs to be done is to be sure that no foreign microorganisms are getting into your container. In the 19 wineries that Professor Cruz worked in, he didn't have very many problems with that, but in one or two wineries he did. Lactobacillus hilgardia was the messy boy. And the same thing is true with Fornichon in Australia. Fornichon reported in a number of cases in Australia that with film yeast, he was getting contamination. So the process of using a film yeast or submerged culture is not one that you just put away and then you go on a vacation and you come back. It requires constant attention. And we think that some of the poor results that were obtained by at least 2 wineries was due to the fact that they were not watching them. One particularly tragic case where a small winery put quite a bit of money and effort, 2 of these occurred, put quite a bit of money and effort, and they were all lactobacillus spoiled before we could get at it. As soon as we called their attention to it and so forth, it was pretty obvious to them what had happened, but in the meantime they had lost the wine, and it was not really possible to make the process reverse itself enough to use the wine. So they had to distill wine that they had paid good money for, which they could hardly afford to do. So I encourage people to do this experiment, but a little care will pay a lot of dividends on the submerged culture. Watch the development of the acetaldehyde, watch the bacteria to see they're viable, make some slides to be sure that you don't have rod-shaped bacteria there. That's the usual spoilage organism under these circumstances. And if they do develop in any great quantity, it may pay you to fortify and stop the process at that stage, or it may, if the process has never really got started, you may want to start all over by SO2ing, filtering, SO2ing, and adding a new yeast culture. Or you may not want to try it at all. You may just want to distill it if you've got really bad conditions. Now, I've been asking myself for some years why there isn't more use of fractional blending. When we worked on this, we used to think that there would be some interest in it, and we still think there are some reasons for there being interest in it. But later it turned out that not very many people are using it, at least not using it in a formal way. Well, let me briefly just describe the process, and then I'm going to go over these equations. I'm not going to write the equations on the board, but I'll show you how they're derived and so forth. And we're just going to use a 3-barrel solera today to make it easy. These could be full or not full. Its process is perfectly applicable to any kind of wine or even to brandies. As a matter of fact, there was some interest in the Internal Revenue Service about changing the law to permit its use for whiskeys and brandies, and we think that maybe that's the best use of it of all, would be to use fractional blending under those conditions, because they do have very large amounts of whiskey in storage, 400 million gallons of whiskey in storage, so that the objection to the fractional blending system that it ties up a lot of liquid would not apply to the brandy and whiskey industry, because there it's already tied up. Has to be tied up for a minimum of 4 years in many cases, and some of it's tied up for much longer than that. So there it would have some easy interest. It's also been recommended for such things as mayonnaise. Mayonnaise factory produces mayonnaise every day, but there are subtle differences in the mayonnaise from one day to the next. The eggs are different from one day to the next. The vinegar is slightly different. The oil is slightly different. They get more air in one and more air in the other one. So it was suggested that they make a 3-step solera for mayonnaise. Today's production, yesterday's production, the day before yesterday's production. And that they always take out of the 3rd step and they keep blending them in. This has some advantages and disadvantages, and I think it was actually tried in Buffalo, New York. Well, anyway, the problem is that you take out of one of these, it doesn't make it on which end you start at, a certain percentage withdrawn, which we'll call P is the percent withdrawn. And we'll say it's 25% in this case. That's a fairly common amount that's withdrawn, 25% in these solera systems. You can make it more, but And if you make it less, they come to equilibrium too slow. So something around 25% is perhaps the best drawing thing. Having taken 25% out of this one, you fill it with 25% from the one just above. And you fill this one with 25% from the one just above. And this is filled with 25% of current production. Now, in this particular case, this was a 3-year-old wine, this was a 2-year-old wine, and that was a 1-year-old wine. So the attempt was made to produce wine of essentially the character of a 3-year-old wine. If you do this once a year or twice a year, and you plot the average age of the wine that's being withdrawn, you will find that at the first drawing off, which we'll call 0, it was 3 years. But now if you wait one more year, this is at the beginning of it, and you wait now another year plus 1 year, most of this wine is going to be 2 years old, most of this wine is going to be 3 years old, and 75% of this wine is going to be 4 years old. So the average age is going to go up. And this is the years of operation, or days of operation, or units of operation. In the case of mayonnaise, it was a 3-day operation, but it could be once a year. Well, the average age went up not quite to 4 at the end of one period, and it will keep going up for several years, and eventually will come to a constant age and will not change thereafter. So the first thing that a solera system does is produce wine of a constant age after a certain period of operation. That presupposes that you draw upon it for 25% each year, more or less 25% each year. If you only draw upon it for 10%, this period before it comes to a constant age will be greatly extended, and the average age will be much higher. About 14 years of age, I believe, in a 3 or 4 step solera. And if you withdraw it much faster, if you take out 40% a year, the average age will not go up nearly as high, will only go up like that, to about 4.5 or 5 years. So the first thing then is the frequency at which you withdraw and the percent you withdraw. There's also some effect of what kind of wine you put in up here at the top. You could put current production wine in, but if your solera is going to be withdrawn, we'll say in September, the wine you put in is already going to be 1 year old. So we at one time calculated the effect of putting in wine of different ages at the top there. Anywhere between 0 and 1 full year of age could be done. Well, this tends to produce not only a constant age, but wine of a constant type, because this is being fractionally blended into this, and this is being fractionally blended into this. The attempt is made to start the solera with wines all of the same general type, and to use as fill-up material current wine of the same general type. So if you do this, you should produce, over a period of time, wines of a fairly constant type. Even if 1 year comes along that is abnormal or of erratic quality of some kind, by the time it's blended down to the first step, to the second step, to the third step, it comes down very gradually as a mixture, and very shortly, and quite correctly, there is not very much change in the character or quality of the last step, or the ones that's being moved out here. Another factor that influences the age of a solera is how many steps deep it is. There are some of these soleras that are 8 steps deep. That Tio Pepe that you had in class is an 8-step solera. Some of the brandies that are aged in Spain are 8 or even 10 steps soleras. We had some samples here once from a 10-step brandy solera in the Sherry district. The disadvantages, of course, are that there's a lot of hand operation, moving the wine from one container to the next to the next. If you attempt to make it into larger containers, then you reduce the surface to volume relationship, hence the aging rate in the case of ports or muscatels or brandies or whiskeys, or if you try and do it in larger containers with film yeast sherry, the surface to volume relationship decreases so that you don't get enough film yeast character. So these operate best when they're operating in medium-sized containers. However, we calculated out that if we were going to run a port solera in California, we thought that 500 to 1,000 gallons might be the ideal size, because there's enough surface to volume in a container of that size that you would get a fairly good aging rate, and you could get a fair amount of volume going through compared with 100-gallon barrels, where I think port in California at least ages too fast. So that there are some possibilities. And I think the same thing would be true of muscatel. I wouldn't want to start a muscatel solera with 50-gallon barrels in California. Oxidize too fast. And I'd rather have much larger containers than that. Well, the cost is one. The possibility of contamination, bacterial contamination, is another one. That you have so many of these containers around, and one of them may start off with a bad bacteria, and eventually that will be moved to all the others. And that's actually happened in the Sherry District. They'll get a bad container on one side, and as they spread the contents of that container to a number of adjacent containers, they don't just move them down directly. They take what they're going to take out of this, the 25 gallons or 250 gallons, whatever it might be, and they'll spread it over 20 or 30 or 40 containers just below it, a little bit into each one. Why, you can see that you could very rapidly contaminate a whole solera from just one or two bad containers. Also, it robs the winery of one of their best public relations things. Namely, you can't say it's a certain age anymore. The government takes a rather dim view of that. And they've practically outlawed all the solera system things unless it's quite clear that the solera represents only a date when a blending system was started. And you can find a couple of Pedro de Mec sherries that will say solera 1850 on them or something like that, 1852. They don't have very much 1852 wine in it anymore, but that's not like saying this is a genuine wine that's 8 years old. It would be much more valuable to them to say that, but of course they can't do that because they don't know exactly how old the wine is. And the government is not just about to let them do that. So that may be one of the reasons why many people don't use this system, because it robs them of the chance of saying that they were using wine selling wine of a certain age. Well, now, if P is the percent drawn off, then Q would be the percent left. And in the first line there, we have, before you draw off, there is wine of aged 1. After the drawing off, you're going to fill it up with P. You took P off, so you've got to fill it up with P percentage of 0 age wine. And you're going to have wine of 1 year left. That's the Q, the portion remaining. P plus Q equals 1 in this particular case. Well, you wait for a year, or 6 months, or whatever the period that you're using is going to be. The wines have aged, in this case it's a year. So the wines at the end of the first line, first two lines, have now moved down to the second line, the end of period 2, and the P portion is now 1 year old, and the Q portion is now 2 years old. Now, at that stage, you're going to take out, you're going to have left P plus Q. You've taken P out, so the amount that's going to be in there after that step is going to be P plus QP plus Q squared. And P is going to be coming from 0 age wine. The QP is going to represent the 1 year old wine, and the Q squared is representing the 2 year old wine. That's what it should have in the last line of the second period. Let's go on to the third line now. At the end of 3 years, you're going to have that P, PQ, and Q squared 1 year older. So P is now 1 year old, PQ is now 2 years old, and Q squared is now 3 years old. At this stage, then you're going to have P plus Q times the amount that you had there before, P plus QP plus Q squared. So that's going to be P plus PQ plus PQ squared plus Q to the third power. And that should be what there is on the last line there. It's P plus QP plus PQ squared plus Q to the third power after you've filled it up. The P is what you put in from the 0 age wine. The QP is 1 year old, the PQ squared is 2 years old, and Q third is 3 years old. All right, that's all in the first barrel after 3 periods. Now let's look at the second barrel, which is the barrel immediately below the first barrel, up above. And it's filled with 2-year-old wine, as I just indicated here on the board. And the 100% of that. After you've taken it off, there's going to be P of 1-year-old wine that you're going to put in it, and Q part of 2-year-old wine is going to be in it. P plus Q. You wait another year on the second line now, and you still have P portion of 2-year-old wine and Q portion of 3-year-old wine. Your P plus Q. Now at this stage, you're going to fill that barrel up with stuff from up on the second line. And what you have in the second line is P plus PQ plus Q squared. So you're going to have P times P plus QP plus Q squared. That's where your P is going to come from up there on the next line. And you're also going to have Q plus Q times P plus Q. Is that right? Well, if you multiply this out, you're going to get P squared plus QP squared plus P Q squared plus QP plus Q squared. And that comes out to be 2 QP squared plus QP plus Q squared plus P squared. Is that right? P squared plus 2PQ plus Q squared, right? Where did they didn't put the QP in there, Mrs. There's no PQ in this one. P squared plus P squared plus QP. Excuse me, do that again. Right. P squared plus QP squared plus PQ squared plus QP plus Q squared. Is that right? QQ. Last direction. No, Q squared. PQ. This is 2PQ squared. QP squared. That's what I had before. That isn't what the book says it is. What did I do wrong? P times P plus Q plus Q plus Q times P plus Q. So there's got to be a QP in there someplace. Oh, I see. There's going to be 0. There's going to be 4 of them. It's right, except that the QP has been left out. There has to be a 0, 1, 2, and 3, because you brought it down from P, which is 0, PQ, which is 1, and Q squared, which is 2. So therefore, you have to have down here a 0 is P squared, and then PQ squared and QP. So there will be, instead of there being 1, 2, and 3, it will be 0, 1, 2, and 3. Please make that change. 0, 1, 2, and 3. And then that one. You're bringing it down from up above, where you're bringing down P, PQ, and Q squared from the barrel just above you. So that's the P part. It's going to be P times P plus PQ plus Q squared. And the part that's remaining is going to be Q times P plus Q. So there has to be a QP, and there has to be 0, 1, 2, and 3, or 4 different lines on that line 2 down below there. From there on, you get then the same sort of thing going on, and you can calculate this for the third barrel down below. If you do this up to about the 7th drawing, you will find that the whole equation comes out the same. It just simply gets older the longer you keep it, but the equation remains the same, and that's why you get this constant age here of wine after a certain period of time. Well, there are several things that are wrong with the solera system. One is that besides the difficulty of calculating the age, which isn't really very difficult, the other problem is that people don't milk their soleras regularly, so they get out of phase, so that one time they're older than another time. Sales demand may continue to go up, and so the solera continues to get younger, not older. That happens very often. It's only very stable industries that can afford a big solera system, where they know that they're going to produce just a certain amount. I've never found any American companies that are willing to have a status quo. Progress seems to demand that they always have more wine as time goes on. And so that's a problem for them. There is a large expense for the amount of tied-up wine there is in these two. But there wouldn't be any more expense than keeping the wine for 5 years or 6 years or whatever average age you wanted to produce. The extra expense would be in the labor costs of moving the wine around. Well, it's only for high-quality wines that a solera system can be used. Now, the other two problems that we have is the questions of port, why there has been so little interest in port in California, why there are practically no real tawny ports on the market. We made a survey here a few years ago, and practically all the so-called tawny ports that were on the market were caramelized from baking. Their brownish color had been obtained by baking, just like baking sherry, exactly like baking sherry, and therefore they didn't smell like a tawny port. They smell like caramel syrup, and or like a sweet sherry in California smells. Now, there's nothing wrong with the caramelized smell. There are several cream sherries in California that are highly caramelized, and they're doing fairly well on the market. That's not the problem. The problem is that they make them too sweet, and that caramel flavor and that very sweet doesn't lead to very much consumer pleasant reaction from tawny ports. I would like to see us try a tawny port of around 6% sugar that got its tawny color just by aging, and see what would happen. Now, there are a few of these that have come on the market, special lots that have been set aside. Most of them have been rather woody. That's because I think they're using American oak. And American oak is pretty soft, and you get a woody character, vanilla character, pretty quick. That's fine if you're going to make brandy, California brandy in them, but for port, that woody character takes away from the character of the port. I'd like to see a natural tawny port then produced that was not too sweet and not too big and not too woody. Let's see what would happen. The ruby ports, we've had a number of quite good ones of these in the market, and we've tasted one in class. There's a new Suzal on the market now. Several Tinta Madeiras on the market. Again, I think as we found out in their tasting in class, they tend to be a little low in acidity. They tend to be rather flat. And building up their acidity, I think, would do wonders for the ruby port. It would make them fresher and fruitier. And some of them are too sweet. The feeling has been in the industry that if they don't make them 12% sugar, they're not really going to sell. I think that may be all right for somebody on 4th and Mission Street in San Francisco who needs the sugar, but the average over-caloried American husband and wife You don't need 3 or 4 glasses of 12% sugar in the late evening. It makes them sleepy and it adds calories like mad. Now, practically no vintage ports have been produced in California. A few ports aged in the Portuguese sense. A few ports that have been aged in the wood for 4 or 5 years have been available and still are available. They're fairly nice, and as long as they don't get too woody, I think that's all right, and not too tawny so that they don't become a real tawny. But the idea of putting down a port in the bottle for aging, the Ficklins have done a little bit of this, but they have never really gotten into it very deeply because the demand, they say, is not very great. It ties up a lot of money in bottles and corks to start with, and you've got to know what you're about. If you do start a vintage port program of aging, put down ports with plenty of color. Otherwise, you're going to get a tawny port out of the bottle, and it's not going to be very interesting. Portuguese put down wines with a lot, and we've done that experimentally too, put down wines with a lot of tannin and a lot of color. They claim these work out much better, and we found that to be true also. And now the other dessert wine that I wanted to say something about was Muscatel. Very frequently neglected in the industry because it got a bad reputation. After repeal of Prohibition, there was a very big demand for Muscatel. Some of you who are complaining about the morals and ethics of the California wine industry vis-a-vis vintage labeling and variety labeling at the present time should have been here in 1938 when Muscats went to $75 a ton and Thompsons could be bought at $35 a ton. And the industry sent a petition to the Treasury Department to declare Muscatel was a non-varietal wine. And they would just by decree, they would decree that Muscatel was a non-varietal wine and didn't have to conform to the 51% regulation. That was just at the time when Orwell's 1972 was out. And so I wrote a paraphrase of that, which turned the trick. I said that just what's going to happen according to Orwell. If you haven't read 1982, it's 1982. 84. All right. If you haven't read it, you should read it, because in it he proves that in the long run the ruling class decrees that black is white and white is black, and that's the way it comes out. So I wrote a paraphrase of that and said that the California wine industry has done Mr. Orwell better. They brought 1984 back to 1938. And there was somebody with a sense of humor in Washington because they buried the petition and we never heard from it since. My sole contribution to the legislative process, I think. One of my few, anyway. The Muscatels were then neglected for a long time. They did not retain their popularity. Through the war, they went down. And I've been looking for reasons for it. One of them, the industry has the idea, and still has the idea, that the best Muscatels are the ones that have an oxidized character. And so there are several wineries producing Muscatels in the valley who, after they make them, will add 5% of port so that they'll get a reddish-brown color to them. And they claim they have better sales of this kind of Muscatel. I can't see that the port does anything for it except dilute the Muscat, and there are other ways of doing that. I think that one of the problems is there's been too much raisin flavor in many of our Muscats. And those of you who are listening to the tour at the Martini Winery will recall that somebody asked about the Moscato Amable, and they said that they were running out. And then somebody else asked him, maybe he didn't do this every tour, but he did it on at least one. And then they asked him why they were running out, and he said, because we couldn't get any Muscats last year from Kingsburg that had ripe grape flavor without the raisin flavor that we could use for making the Moscato Amable. So I think that same degree of conscientiousness has not percolated into the Muscatel industry in California. Many years the Muscats at Kingsburg, which is supposed to be our best Muscat district, don't get ripe at all. They're just great big green Muscat of Alexandria grapes. In other years they're all raisin before you can turn around. They have a small crop and you get hot August weather and the Muscats raisin very badly. And it's only in when conditions are quite favorable, that you get those nice golden colored, non-raisined, full of muscat flavor wines that the Martinis want for their Moscato Amabile, and what anybody that wants to make a high quality muscatel should look for and try to produce if he can. I don't know what the status of muscatel as to put in new plantings of muscat for making muscatel would be. There are several sweet muscats now in the valley. Christian Brothers has a, which we tasted in class, the LaSalle muscat, which is Alexandria based primarily. There is, Mondavi has a new muscat, which is a sweet table wine. And I understand there are 2 or 3 more of them running around on the wings. It'll be interesting to see whether they can develop for the non-dessert wine muscat market around 10 or 12% alcohol with some sweetness and muscat flavor. The other problem with the muscatels is they spoil very quickly. They're the most spoilable wines. In the 1936 epidemic of cottony mold, it started out in the muscats, and the worst contamination was in the muscats. Just in finishing, you might like to hear the history of that. After the 1936 vintage, as they began to ship dessert wines to eastern United States and bottle them, a good deal of the bottling was done in the East at that time. By about March of 1936, we began to get samples from the East, and they began to come to Berkeley and to here, bottles which looked like a ball of cotton in the bottom of the bottle. Sometimes about a ½ inch thick, sometimes as much as 3 inches up in the side of the bottle. Awful looking stuff. We were shipping wine back almost as fast as we were shipping it to the East. And Douglas was the microbiologist at Berkeley at the time, and Vaughn had just come. Pfaff was still a graduate student, I believe, or just got his degree at that time. And Professor Cruz and other people all took a hand in it, and it was identified primarily as Lactobacillus hilgardia, and it was found to be very sensitive to SO2. So by the fall of 1937, all the wineries had learned the dangers of these contaminated fermentations of sweet wines in the valley. There was a lot of SO2ing. A lot of wines were pasteurized to clean up the cellars, because the whole cellars had become contaminated by that time. And by the end of 1937, there were very few complaints, and we haven't heard any since the war. In fact, we've been looking around for a typical example of Fresno mold, or cottony mold as it was called in those days. There is one report in the literature 2 years ago of an Italian vermouth with typical Lactobacillus hilgardia growth, describing the filament of cotton in the bottom of it. This was a wine of about 16% alcohol, and undoubtedly made out of muscats, or partially made out of muscat. So beware of these muscats, which are very high in pH. The 1936 muscats ran 4 in pH quite regularly. And under those conditions, you get a lot of contamination of muscats. And if you get lactobacillus growing in them, they're resistant up to 17 and 18% alcohol. And the only thing that we found at that time to control them was SO2. And the other thing was to bring the alcohol right up to 20.5. And that accounts for the fact that from that day right up until last July, the minimum alcohol content on California dessert wines was 19%. That reflects the losses, the hysteria that went on in the 1936 and 37 vintages in California. But finally, as the technology caught up, it's very rare to get a spoilage anymore, and so we lowered the alcohol contents as of last year down to 17 and 18. All right, don't forget to give us lots of questions on Monday. I should have said that I've been cleaning my office out, and a couple years ago I did a science report on the search for good wine.